The lakes that are found high in the mountains are linked to the sea.
Bubbles
appear in the water, and the bubbles make the connection. That is how we communicate with the lakes and the sea, and with the mother. The waters speak.
The waters speak.
Kinuha apa yang gue habahan gue kau. Nama aja. Ai awak yang apa yang gue nama aja. Nama aja. Nam. Mulai tu musik kabaj gue. Shui acha minggu tu. Ya.
I'm sorry, but the bubbles don't speak to us. We have to see the connection within this one.
Most of the Earth's bubbles are here, in the oceans. They're formed as breaking waves drag air underwater. These are the bubbles I study. And the reason I study them is that bubbles influence the way the oceans and atmosphere interact. And they do so in ways we're only just beginning to understand. I observe bubbles at sea, and I also study them in great detail in my lab. Here, I can replicate the great variety of conditions that exist in our oceans. So what I can do with this tank is basically make it into any region of the ocean that I want. So it might be somewhere in the tropics with a high water temperature and lots of phytoplankton. It might be somewhere in the Southern Ocean, the water's very, very cold, not so much growing, and I can watch how the bubbles form in all those different situations in the ocean. And what's happening is that down at the bottom there is a nozzle, and it's bubbling away, so it's producing lots of bubbles, and those bubbles rise into a region where there's two tubes coming down on either side, and they're pumping water out. And so those bubbles rise up in a straight line, and then they hit this region of turbulence, and that's just like what happens to bubbles underneath the breaking wave. The reason for trying to understand bubbles is that out in the ocean they play an important role in our climate. One part of that role especially is brilliant because it's so surprising. When they rise to the top and they form that foam, the white horses on the ocean surface, they are spitting tiny particles up into the atmosphere, and those particles can be bits of salt, or they can be sort of organic material that was stuck to the bubble, and they all get spat up into the atmosphere, and that matters. And I love, this is one of my favourite facts in sort of bubble science. Those tiny particles that get spat upwards help clouds form. So in a cloud in the atmosphere, all the droplets have at their centre a little speck of dust of some sort. And especially over the open ocean, the clouds quite often at their centre have a little speck of dust that was spat out of the ocean by a bubble. And ocean bubbles aren't just a one-way street. They also help carry gases like carbon dioxide and oxygen down into the water. And so these transport mechanisms, the fact that the bubbles help gases move around and help particles move around, is really important for weather and climate because it's basically changing the chemistry of both the atmosphere and the ocean. So you can see why knowing how many bubbles there are and how big they are would help our climate models. And this is the equipment I'm using to do this. It records bubbles responding to sound. In principle, by analysing these recordings, I can calculate how many bubbles there are in a particular part of the ocean. And equally important, I can estimate how big they are. The idea behind how this works is quite simple. And so you can see now very clearly that there's this long period oscillation that's the bigger bubble. And this has a frequency of 1.7 kilohertz, tells me that the bigger bubble here was about 2 millimeters in radius, and the frequency of the other one is 16.5 kilohertz, and that tells me that this bubble here was about a tenth of the radius. So this one is about 0.2 millimeters in radius. And you get all of that information just from looking at that sound signal. And this is why sound is such a powerful technique to use in the ocean, because all you have to do is listen and you get this huge amount of information about what just happened. It's early days. There's much more work to do to compare the laboratory results with our measurements at sea. But one day, I hope to be able to estimate not just how many bubbles form and how big they are, but exactly when and how they matter most. And then that information can be added to our climate models. By understanding bubbles, we'll have a better understanding of our planet. At the beginning of this film, I quoted Lord Kelvin talking about the physics that we can learn from bubbles. I hope that I've persuaded you that what you might have thought of as beautiful toys are enormously powerful scientific tools. They can help us explore nature at scales that are normally beyond our reach. They have surprising practical benefits too, in diverse fields such as ship design and medicine. I hope that from now on, you'll see bubbles in a completely different way. Imagine just one bubble and all the things it does while it exists. And then remember that underneath every breaking wave, there are millions of bubbles. And under every storm out at sea, there are millions of breaking waves. And on our planet right now, there are tens or hundreds of storms going on. So overall, on Earth right now, there are billions of bubbles out there. And the key to understanding all of what those bubbles are doing is understanding just one object, one little bubble. And the thing about bubbles is that once you know a little bit about them, you start seeing them everywhere and start appreciating what they're doing. And so understanding just one physical principle means that you start spotting it everywhere in your everyday world. So just one bit of physics can make your life so much richer.